Hi there. We're feeling pretty good about this talk, to be honest. I'm going to show you these charts as we go. Um, so we're rocking it. We're feeling pretty good about things. These are all kind of sitting up in the threes and fours. This is our lowest things, talking about oxidation numbers and deciding what's oxidized and what's reduced. Overall, in general, you guys think I'm doing okay here, so that's good. You either said I am spending 30 to 40 minutes a day on this, or I'm spending over 40 minutes a day, but it's because I'm watching the video and you're okay with that. And then these are the same. So the only the bad one is a green, and I don't see any green in here. Everyone else was like, I'm okay with it. So that's good. I felt pretty good about that. I'll keep doing what I'm doing. Today I'm not really talking about much. I just want to talk about the free response and the number 5. So, yeah, number 5, I don't know why I didn't catch that, but I did it on the computer program, and then it made the PDF, and I didn't see how it ended the PDF. So I'm sorry, number 5. I don't even know what's going on there. We're just completely skipping it. It's fine. And looking at the free response stuff, the first I want to talk about is this problem here, deciding what's oxidized and what's reduced. So a lot of people were identifying the correct thing that was oxidized and reduced, but we were not using the correct kind of oxidation numbers. So that's kind of what I wanted to show. So this is the equation, and when you want to decide redox numbers, there's a couple different rules to go from. I don't really know what Levinson taught you, but this is the way I do it. So right here, this is a +1, so I know that's the oxidation number. When I'm looking at anything like these, oxygen is always a -2. There's only very few cases where it's not, and that's when it's a peroxide, so I just assume it's always a -2. And I'll know that it's not a -2 and it's a peroxide when things don't add up right. This isn't that case. So right here, this whole thing has to add up to a -1. I've got -2 times 4, that makes a -8. So I just say to myself, what plus a -8 equals a -1, the total it would add up to. So that's a +7. A lot of people are getting this manganese wrong for their oxidation numbers. Moving over. Then I want to look here. Hydrogen's always a +1. There's very rare cases on when it's not, and that would be when a hydrogen's on the backside. It's an ionic compound. So you would obviously recognize that because you would look at the two oxidation numbers and it wouldn't add up. So in general, when I do oxidation numbers, oxygen's a -2, hydrogen's a +1, and I figure all the rest out from there. So here's a -2. So then they got to all add up to 0 because this is a neutral compound. So 2 times 4 is a -8. I don't know what C is, but I know that there's 2 hydrogens, so this is a +2. So my question mark here has got to add up to a +6, and it's for 2 carbons, so that means each carbon must be a +3. Carbon is a +3. Moving over, I look at oxygen here. He's a -2, and there happens to be 2 of them, so that's a -4 side. It has to add all the way up to 0, so that means carbon's got to be a +4. Moving over, oxygen's always a -2, hydrogen's always a +1. I do a double check. Yep, this looks good because H, 2 of them would be a +2, oxygen's a -2, it all works out. And then over here I got manganese all by itself, and it has a 2+ charge, so its oxidation state is also a +2. So then in order to decide who's oxidized and who's reduced, I look at who changed from left to right. Manganese is a common thing to change. So I'm drawn to manganese. It went from a +7 to a +2. The only way you can do that is to gain negative stuff. So this happened to gain 5 electrons. If you gain electrons, you're reduced. The other thing that was changing here is my carbons. It went from a +3 to a +4. And the only way you can become more positive is if you lose negative stuff, or in other words, you lost electrons. And that would mean you're oxidized. Lose electrons is oxidized. So that would be that. The original question was saying who was reduced and justify in terms of oxidation numbers. So you had to talk about oxidation numbers and you had to talk about them correctly. So that's why who was reduced, it would be the manganese was reduced, or you could say the MnO41- was reduced because the +7, the manganese went from a +7 oxidation state to a +2 oxidation state. Okay, the other thing I wanted to talk about was the burettes and the sig figs. That seemed to get people just a little bit, so let's just kind of talk about that real quick. Okay, so when I look at this, the first burette, I'm looking at its 3 point, oh, that. Okay, so if I look at the first burette, I'm thinking it's about 3.38 or something like that. The other burette over here, I can see it's at 29 point, not 6, not 7, between there's 0.65. Now I know that it's 0.6 something because I have a mark for 0.6 and I have a mark for 0.7, so I'm saying it's like in between there. So now if I want to subtract the two, 3.38 minus 29, subtracting the 2 to figure out what was my total volume that went in. I'm terrible at math in my head, so I have to go old school on this. 26.23 is what I got when I did it this time. Now, a lot of people were saying, but I thought because this was 3 sig figs, and then this is 4 sig figs, the lower number would be 3 sig figs, this should really just be 26.2, but that's not true, because we have to use our subtraction rules. That's when you got to line them up old school, which is exactly what I did here, and I see they both go to the point something something, so that means I know my answer has to go to point something something. That rule of 3 sig figs, 4 sig figs, it doesn't really apply because that's multiplication and division, and we're looking at subtraction. So I will say that the past couple tests, they have had their sig fig question. They have one sig fig question every year, and that sig fig question has been on the free response. Now we're only doing free responses here, so it's it's up in the air if they're going to put their sig fig on there or not. But if they do, it's always this way. It'll be a graduated cylinder or it'll be a burette, and it's always a subtraction or addition problem because everybody knows how to do the other ones. So I would think about that. I take it back. Not always. I can remember one problem that was a multiplication one, but nope, it was linked to subtraction too. So yeah, add or subtract, something like that. They like to do it with the thermometers too, so keep that in mind. Somebody did ask about the AP test. Are we going to be taking that at home or at school? If we are in, from what I know, there's a big spiel here tonight, so I didn't read the memo on that yet, so I got to get on that. But from my understanding right now, we're going to take the AP test on your computer at home. Now, if we happen to be in school in May when they actually take it and it's during the day, then I think the school is going to set up a time when we're going to be taking it during school. I could be wrong on that. I'm going to have to bet, my money would have to be bet on you're going to be taking it home on your own computer. The good news is you'll be able to write like in, when you have to do math, you don't have to type out the math. You can write it in hand and then take a picture and scan it in. That I know for a fact. It's also basically going to be open notes. So we're going to talk about that later on too. So it's like an open note test, which is a good thing and a bad thing, right? You can just make it harder. Okay. Yeah, that's what I got. Here's your thing of the night. Because that's all I got to talk about. My daughter and son have been drawing a lot, so it is guess the picture. Guess what that is. Nope, you're wrong. It's a pumpkin carved into an elephant with a crown on top. Guess the picture. Yes, it's lots of cars. She's very good at it. Guess the picture. Nope, you're wrong. It is her best buddy. That means it's her stuffed animal friend as an octopus. Guess the picture. Nope, you're wrong. It's not a puppy, it's an elephant. The kids have told me this, so it's not just me telling you. Guess the picture. Yep, this one's a little frightening to me too. I'm not sure. I actually don't know what it is, but it has 21 legs. That's all I know. Guess the picture. This one I know for sure is an elephant. It does have a lot of legs, you might be wondering. Yes, it does, but it is an elephant by my son. He's 4. Guess the picture. Yep, it's got some people, and this one right here is a snowman. Guess the picture. Yep, it's an elephant. You're wondering, like, why do your kids draw a lot of elephants? They love elephants. It's their favorite animal. I don't know. Guess the picture. I don't know. It's by my son again, and it frightens me also. I'm not sure. Why bright red? I don't know. They know that's my favorite color, but I don't know. Guess the picture. If you're guessing elephant because that seems to be the trend, you're correct. It is an elephant. That went a little funny. These are the 4 arms, and this is the trunk, and then his face. I don't know. Guess the picture. Yeah, it's just scribbles. Yeah, that one's just scribbles too. Guess the picture. No, I wish it was ice cream. It's actually snowmen. Really, really tall snowmen. She thought it was hilarious. Have a good night. Don't have bad dreams from the all red one. I'm sure it's a lovely creature. I should ask them about it. I'm sure it'll be just all happy dreams and everything. The red 21-legged thing is not, my son's not creepy.